You know, have you ever been just swamped by some really complex task? Like something with loads of steps, decisions, and you just wish you had, I don't know, some software that could just handle it all by itself?
Oh, absolutely. We've all been there.
Yeah.
And that feeling, that's kind of where today's topic comes in.
Right. So we're talking about something more than just like basic automation.
Exactly. We're diving into agents. Think of them as, well, LLM-powered systems, but built for real autonomy. They can actually manage and run entire workflows pretty much independently to get something done.
Okay, agent. So not your average chatbot then.
Not at all. Way beyond that.
Yeah.
It's like having a digital team member who can genuinely take a complex project and see it through from start to finish.
Interesting. And we're basing this deep dive on, I understand, a pretty practical guide, something focused on actually building and using these things in the real world.
That's right. It draws on insights from actual deployments, so it's grounded in what works, in practice.
Okay, good. Because I bet a lot of listeners may be dealing with really complicated decisions or tangled up rules or just tons of like messy, unstructured info. They're probably thinking, how could this apply to my work?
And that's exactly what we want to unpack today. Our goal here is really to give everyone a clear picture of what these agents are, figure out when they're genuinely the right tool for the job, and break down their core building blocks.
But without getting totally lost in the weeds, technically speaking.
Exactly. Focus on the concepts, the why, and the how at a practical level.
All right, sounds like a plan. So let's kick things off. What is an agent, fundamentally? How is it different from, say, software we already use, or even those simpler LLM integrations we see popping up?
That's the crucial starting point, yeah. Conventional software, it automates predefined steps. Your basic LLM tools, like a simple chatbot or maybe a sentiment classifier, they help with specific interactions.
Right, one-off tasks, mostly.
Exactly. Agents, though, they're a significant jump. They don't just follow a script you wrote. They actively manage and control the execution of a whole workflow. They use the LLM to figure out the path forward based on the goal you give them.
So the LLM is kind of the brain steering the ship.
Precisely. It's the orchestrator. It decides what needs doing, when, how to do it, step by step, to reach that end goal. It's really about that autonomous control over the workflow process itself.
So it's making decisions along the way. It's not just a response machine.
Spot on. That independence is built on, well, a couple of core ideas.
Okay, lay them out for us.
First, the agent uses that LLM, its core intelligence, to manage the whole process end to end. And it makes decisions dynamically as things change or new information comes in.
Dynamically, so it can adapt.
Yeah, and what's really key here is its ability to self-correct. If it hits a roadblock or maybe sees a better way to do things, it can actually adjust its plan on the fly.
Wow, okay.
Wow.
That's pretty advanced.
It is. And importantly, there's a built-in safety net. If it gets really stuck, like truly can't figure out the next step or resolve an error, it's designed to halt execution and hand control back to a human user. It doesn't just keep going down a wrong path indefinitely.
That's crucial. So self-correction, but with a human fallback. What's the second core idea?
The second thing is its access to tools. These are basically external functions or APIs. Think of them as the agent's hands and eyes on the world. They let it interact with other systems.
Well, like databases or other software.
Exactly. Databases, CRMs, external web services, sending emails, you name it. Anything you can connect to via an API, potentially.
Yeah.
And the agent doesn't just have a fixed set of tools it always uses in order.
No.
No, it dynamically selects the right tool for the job based on where it is in the workflow and what needs to happen next. It figures out, okay, now I need to query the customer database, or now's the time to send that confirmation email.
And it does the selection process itself.
Yes, intelligently choosing the appropriate action. But, and this is important, always within defined boundaries. It can't just go rogue and start using tools randomly. There are guardrails, which we'll definitely talk more about later.
Okay, makes sense. Intelligence to decide, tools to act, and guardrails to keep it safe. That gives a much clearer picture. But, this sounds powerful, maybe even complex to build. When should someone actually think, yeah, an agent is the right approach here? It can't be for everything, right?
No, absolutely not. You've hit a really critical point there. Agents aren't a magic bullet for every problem. They shine in specific types of workflows, usually the ones where, frankly, traditional automation methods kind of struggle or fall short.
Okay, like what? Where do those older methods hit a wall?
Well, one big area is complex decision-making. Think about tasks that require nuanced judgment, not just following a simple checklist.
Can you give an example?
Sure. Take payment fraud analysis. A traditional system might use a fixed set of rules, right?
Hmm.
Like flag transactions over X amount or from certain IPs, or if there were too many failed login attempts. It's very checklist driven.
Yeah, pretty rigid.
Right. An LLM agent, though, can function more like a seasoned human fraud investigator.
Mm.
It can look at the bigger picture, the context. It might spot subtle patterns or anomalies that don't trigger any single hard-coded rule, but, collectively raise a red flag. It's bringing that context-aware reasoning to the table.
So it's less about black and white rules and more about shades of gray.
Exactly. Another example is, say, handling refund approvals in customer service. Instead of just a strict refund if returned within 30 days rule, an agent could potentially weigh factors like the customer's purchase history, the specific reason for the return, maybe even the sentiment in their request to make a more, equitable decision.
Okay, so it can handle ambiguity better. What's another area?
Another place they excel is where you have workflows governed by rules that are just really difficult to maintain, those systems. Built up over years, layers upon layers of complex, interconnected rules.
Oh, yeah. Terrifying to update sometimes.
Exactly. They become brittle, hard to change without breaking something else. A good example here might be performing vendor security reviews. The security landscape, compliance rules, they change constantly. Maintaining a massive static rule engine to keep up is a huge chore and prone to errors.
So how does an agent help there?
An agent, trained on the principles of security assessment and maybe fed the latest compliance docs, can adapt much more fluidly. It's reasoning based on current best practices, rather than just matching against thousands of potentially outdated specific rules.
Well, that makes a lot of sense. Less brittle, more adaptable. Is there a third key area?
Yes. The third one is workflows that rely heavily on unstructured data. This is a big one. We're talking about natural language text from emails, chats, documents, transcripts. Traditional automation is often pretty bad at extracting meaning and context from this kind of messy, human-generated stuff.
Right. Structured data is usually easier for machines.
For sure. So think about processing a home insurance claim. You've got the policyholder's description of what happened, that's natural language, maybe photos they submitted, the actual insurance policy document itself, which can be long and complex.
Lots of different formats and types of information.
Exactly. An agent equipped with the right tools, maybe one to read PDFs, one for image analysis, one to understand the user's text, can potentially ingest all that diverse, unstructured information, pull out the key details, and move the claim forward. A traditional system relying only on structured data fields just couldn't handle that complexity.
So basically, if your process involves understanding documents, emails, conversations, an agent might be a really good fit.
It could be a game changer in those scenarios, yeah.
Yeah.
But, and this is the important caveat,
Always a but.
well, it's a practical one.
Yeah.
Before you jump into building an agent, you really need to validate.
Mm-hmm.
Does my use case clearly fit one or more of these categories?
Mm-hmm.
Complex decisions, hard to maintain rules, heavy unstructured data reliance. Because building agents is more complex than traditional automation. If a simpler, deterministic solution, maybe a well-designed rules engine or a standard workflow tool can do the job effectively, that's often the better path. Less overhead, easier to manage, probably cheaper. Don't bring in the heavy artillery if you don't need it.
Good advice. Don't over-engineer it. Okay, so we know what they are and when they're useful. Let's get into the nuts and bolts. How do you actually build one? What are the core pieces?
Right. Fundamentally, every agent is built on three main pillars. You've got the model, the tools, and the instructions.
Model, tools, instructions. Okay, let's break those down. Starting with the model, there's so many LLMs out there now. How do you pick the right one?
That's a really good question, and yeah, the landscape is changing fast. Model selection isn't trivial. Different models have different strengths and weaknesses, right? Some are better at complex reasoning, some are faster, lower latency, some cost less per query.
So it's a trade-off.
Often, yes. And the guide actually suggests something interesting. You don't necessarily have to use the same model for every part of your agent's workflow.
Oh, you can mix and match.
Potentially, yes.
Hmm.
For a really complex workflow, you might use a very capable, maybe more expensive model for the critical decision points where you need top-tier reasoning. But for simpler tasks within that same workflow, like just fetching some data or doing a quick classification, maybe a smaller, faster, cheaper model is perfectly fine.
Like using the right tool for each specific job within the bigger job.
Exactly like that, optimizing for performance and cost. So the practical advice the guide gives for getting started is pretty smart.
What do they recommend?
They suggest you start by prototyping your agent using the most capable model you have access to for all the tasks initially.
Why start with the Rolls-Royce?
To establish a performance baseline, You want to see what's possible, what's the best result you can theoretically achieve with the smartest model. That gives you your benchmark.
Okay, makes sense. Find the ceiling first.
Right. Then, once you have that baseline and you've got good evaluation metrics in place, you start experimenting. Try swapping in smaller, faster, or cheaper models for specific steps in the workflow. See if the performance stays within an acceptable range for those steps.
So, iterative refinement.
Exactly. You figure out, okay, for this part, the smaller model is good enough, saves us money and time. But for that critical decision, nope, we really need the power of the bigger model here to maintain accuracy.
So the principles are baseline with the best, focus on accuracy first, then optimize for cost and speed by trying smaller models where it makes sense.
You've got it. It's a methodical way to approach it.
Okay, solid strategy for model selection.
Yeah.
Now what about tool? You said these are the agent's way of interacting with the world. How do you define these effectively?
All right, tools are absolutely crucial. They bridge the gap between the agent's thinking and taking actual action or getting needed information. Usually, these are implemented as API calls, using standard stuff like REST APIs to talk to other applications or services.
But what if you have older systems, legacy stuff without nice modern APIs?
Yeah, that's a common problem. The guide mentions an interesting solution for that, using what they call computer use models. These are basically models trained to understand and interact with graphical user interfaces, GUIs.
Like they can see the screen and click buttons.
Kinda, yeah. They can learn to navigate menus, fill out forms, click buttons, just like a human would, by processing the visual layout. It's a way to automate interaction with systems that weren't built with APIs in mind.
Wow, that's quite a workaround. So whether it's an API or one of these UI models, how do you make sure the agent knows how to use the tool correctly?
Standardization is key here. The guide really emphasizes having well-defined, standardized definitions for each tool. This makes them more reusable. Maybe multiple different agents could potentially use the same customer lookup tool, for instance.
Like building a library of shared capabilities.
Exactly. Good documentation for each tool is vital. What it does, what parameters it needs, what it returns. They need to be well tested, too. This helps with discoverability across teams, makes versioning easier, and stops people from reinventing the wheel and building slightly different tools that do the same thing.
So good software engineering practices apply here too. Documentation, testing, reusability.
Absolutely critical. And the guide breaks tools down into roughly 3 main categories based on what they do.
Okay, what are the categories?
First, you have data tools. Their job is to fetch information, to provide context for the agent. So think querying a database, looking up a customer in a CRM, reading relevant sections from a PDF document, maybe doing a specific web search for current information.
Getting the facts. Got it. What's next?
Second, action tools. These are the ones that actually do something, change something in another system, creating a new support ticket, updating a customer record, sending an email or a text message, maybe handing off a complex customer issue to a human agent through a help desk system.
Okay, data to understand, action to execute. Makes sense. What's the third type?
The third category is kind of meta, orchestration tools. This is where an agent itself can act as a tool for another agent.
Whoa, okay. Agents calling other agents.
Yeah. It's a powerful concept for building more complex systems. We'll touch on this again when we talk about multi-agent patterns, specifically the manager pattern. But imagine you have a specialized agent whose only job is processing refunds. Another, more general customer service agent could call this refund agent like a tool when a refund is needed.
So you build specialized little agent tools.
Exactly. You might have a research agent or a writing agent or that refund agent. It allows for modular design.
Very cool. Okay, so we have the model, the brain, the tools, the hands, eyes. What about the third pillar, instructions? How important are they?
Oh, incredibly important. You can have the smartest model and the best tools, but without clear, high-quality instructions, the agent might not behave the way you want or need it to. Instructions are the explicit guidelines, the guardrails, the standard operating procedures that define the agent's behavior and constrain its decision-making.
So they keep the agent on track and doing the right thing.
Precisely. Good instructions reduce ambiguity, improve the quality of the agent's decisions, and ultimately lead to more reliable and efficient workflow execution. Fewer mistakes, basically.
It sounds like writing a really, really detailed manual for the agent.
That's a great analogy. And the guide offers some solid best practices for crafting these instructions. One big one is to leverage existing documents you already have.
Like what kind of documents?
Things like your company's standard operating procedures, SOPs, maybe existing customer support scripts or call flows, internal policy documents. If you've already documented how a human should perform a task, that's often a fantastic starting point for instructing an agent.
So don't reinvent the wheel if you already have process docs.
Exactly. In customer service, for example, maybe each article in your knowledge base could form the basis of a specific routine or instruction set for the agent handling related queries.
Makes sense. What else makes for good instructions?
Another key practice is to structure the instructions, or prompt the agent itself, to break down complex tasks into smaller, distinct steps. Bite-sized pieces are easier for the LLM to follow reliably and reduce the chance of it getting confused or going off script.
Keep it simple, step by step.
Right. And related to that, you need to define clear actions for each step. Every instruction should ideally map to a specific, concrete action the agent should take or a specific output it should produce, like ask the user for their order number or call the Get Order Status API tool with the provided order number. Be explicit. Don't leave room for interpretation.
Specificity is key, no vagueness.
Absolutely, even down to suggesting the exact phrasing for user-facing messages if consistency is important. And finally, good instructions need to capture common edge cases.
The tricky bits. What happens when things don't go perfectly?
Exactly. Real interactions aren't always neat. What if the user doesn't provide all the needed info? What if they ask an unrelated question mid-flow? Your instructions need to anticipate these common variations and provide guidance. Maybe include conditional steps.
Yeah.
If the user provides an order number, then call the API. If not, then ask for the order number again, or define specific branches for handling interruptions.
So you need to think through the what-ifs beforehand and build them into the instructions.
That's the goal for robust performance.
Yeah.
You're essentially trying to pre-program how to handle deviations from the happy path.
Got it. And I think you mentioned earlier some advanced models might even help write these instructions.
Yeah, the guide notes that you could potentially use capable models, maybe like an O1 or O3 mini, to help generate initial instruction drafts by feeding them your existing documentation, like SOPs or policy docs. They even provide a sample prompt for how you might do that. It could be a real time saver.
Definitely something to look into. Okay, so model, tools, instructions, we've got the components. Now, how do we put them together to actually run a workflow? This brings us to orchestration, right?
Exactly. Orchestration is all about how you coordinate these pieces, the models, tools, and instructions to execute those end-to-end workflows. It's about the overall architecture of your agent system.
And the guide suggests starting simple here.
Very much so. The recommendation is definitely an incremental approach. Don't try to build a super complex, multi-agent swarm intelligence from day one. Start with simpler patterns and build up autonomy gradually as you learn and as the use case demands it.
Okay, so what are the main ways to orchestrate?
Broadly speaking, the patterns fall into two main categories: single-agent systems and multi-agent systems.
Let's start with the single-agent approach. Sounds simpler.
It generally is.
Yeah.
In a single-agent system, you basically have one core LLM instance. It's equipped with all the necessary tools for the workflow, and it follows a comprehensive set of instructions, operating in a loop to get the job done.
One brain managing everything.
Pretty much. And you can often handle quite a lot of complexity just by adding more tools to this single agent. Each new tool gives it a new capability. This usually keeps the overall architecture simpler to manage, test, and maintain compared to coordinating multiple separate agents.
So you just keep bolting on tools as needed.
Within reason, yes.
Mm.
A key concept here is the run. The agent essentially operates in a loop, making decisions, calling tools, getting results back, deciding the next step, until some exit condition is met.
What kind of exit conditions?
Could be several things. Maybe the agent successfully calls a specific tool designated as the final output tool. Or the model generates a complete response directly to the user without needing any more tool calls. Or maybe it hits an unrecoverable error. Or it could just be a limit on the number of turns or steps allowed in the interaction. The guide mentions a runner.run method in their SDK as an example of implementing this loop.
Okay, so it keeps going until it's done or hits a limit or breaks. How do you manage the instructions if the workflow gets really complex with lots of branches and possibilities? Doesn't that single instruction set become huge?
That's a great question, and it leads to a useful technique: prompt templating. Instead of writing dozens of slightly different rigid prompts for every possible scenario, you create a single, more flexible base prompt. This prompt includes variables or placeholders.
Variables, like what?
Things that change based on the current situation, maybe the customer's name, the specific issue they're reporting, the history of the current conversation. The agent dynamically fills in these variables in the template for each turn. So you maintain one core prompt structure, but it adapts. The guide gives an example of a call center agent prompt that uses variables for context, history, and available tools.
Ah, so one adaptable template instead of many static prompts. That sounds much more manageable.
It really is. For many cases, it simplifies maintenance and evaluation significantly.
But presumably, there's a limit. When does even a sophisticated single-agent system with templating start to break down? When should you seriously consider moving to multiple agents?
Yeah, there are definitely tipping points. The general advice is to push the single-agent approach as far as you reasonably can first. Adding more agents adds complexity in coordination and operation, but there are a couple of key indicators that suggest it might be time to split things up.
Okay, what are the signs?
One is just highly complex logic. If your main prompt template starts looking like a giant nested mess of if-then-else statements, trying to handle too many distinct paths and conditions, it just becomes really hard to read, maintain, and debug reliably. If scaling the logic within that single template feels painful, distributing it across specialized agents might be cleaner.
So if the instruction logic itself gets too convoluted.
Exactly. The other main indicator is what the guide calls tool overload. And this isn't just about having like hundreds of tools. It's more about functional similarity or overlap among the tools.
Oh, so
If you have many tools that do very similar things, maybe with slightly different parameters or accessing slightly different systems, it can become confusing for the single agent to reliably choose the exact right one in every situation. It increases the chance of errors.
So too many similar options can be paralyzing, even for an AI.
Kind of, yeah. Now, before jumping to multiple agents just because of tool overlap, the first step should always be to try and improve the clarity of your existing tools. Can you give them more descriptive names, define their parameters more clearly, write better descriptions of what they do and when to use them? Sometimes just cleaning up the tool definitions solves the problem.
Try to fix the tools first. Makes sense.
But if you've done that, and the agent still struggles consistently because the available actions are too numerous or too similar, then splitting the responsibilities across multiple agents, each with a smaller, more focused set of tools, might be the answer.
Okay, complex logic or tool overload pushing you towards multiple agents. So let's talk about multi-agent systems. How do they work together?
Right. So multi-agent systems involve, well, multiple agents coordinating to achieve the overall workflow goal. You can often think of these systems visually as graphs, where the agents are the nodes, and the connections between them, the edges, represent things like tool calls or handoffs of responsibility.
Like a little network of agents.
Exactly. And the guide highlights two main architectural patterns that they've seen work well in practice for these multi-agent setups.
What are they?
The first is the manager pattern, sometimes also thought of as agents as tools.
Okay, manager pattern. How does that work?
In this setup, you have one central manager agent. Its main job is to orchestrate the overall workflow. And it does this by calling other, more specialized worker agents as if they were tools.
Ah, connecting back to that orchestration tool category you mentioned earlier.
Precisely. So the manager agent understands the high-level goal. It figures out which specialized agent needs to handle a particular subtask. It calls that worker agent, using a tool call, maybe passes it some necessary information. The worker agent does its specialized thing, maybe translation, maybe data analysis, maybe content generation, and returns the result to the manager.
And the manager puts it all together.
Exactly. The manager synthesizes the results from potentially multiple worker agents and presents a unified response or takes the next overall step. From the user's perspective, they're typically just interacting with the manager agent, so the experience feels seamless, even though there's a team of specialized agents working behind the scenes.
So the user talks to the boss, and the boss delegates.
That's a perfect analogy. This pattern works really well when you need that central control point, someone coordinating the overall flow, and especially when that central agent is the one facing the user.
Any examples?
The guide uses a great example of translation. Imagine a manager agent gets a request. Translate this paragraph into Spanish, French, and Italian. The manager doesn't do the translation itself. It calls a specialized Spanish translation agent as a tool, a French agent, and an Italian agent. Each worker does its translation. They send the results back to the manager. The manager then bundles these up and gives the user all three translations.
Clean separation of concerns. Makes sense.
Yeah. And the guide briefly touches on different ways to implement this coordination. Sometimes it's declarative, like defining the connections in a preset graph. Other times it's more code first, like using an SDK allows, which gives more flexibility for dynamic workflows where the path isn't always known up front.
Okay, flexibility is good. So that's the manager pattern. What's the other main multi-agent pattern?
The other one is the decentralized pattern. Here, agents act more like peers, handing off control directly to each other.
So no central boss.
Not necessarily, no. In this pattern, an agent might handle part of a workflow, and then, based on the situation, directly hand off the entire task, including the conversation history and current state, to another specialized agent who's better equipped for the next phase.
Like passing the baton in a relay race?
Exactly. These handoffs are typically one way. Agent A hands off to Agent B, and the Agent B takes full ownership of the interaction from that point forward. Agent A usually steps out.
When would you use this peer-to-peer handoff approach?
It's optimal when you don't really need that central controller managing everything or synthesizing results. It's great when different parts of a workflow are clearly distinct and can be fully handled by specialists who can take over completely.
Can you give an example?
Customer service rating is a classic one.
Yeah.
You might have an initial triage agent that just figures out what the customer needs. Based on the issue, is it a technical problem, a sales question, a billing inquiry? The triage agent directly hands the customer off to the appropriate specialist agent. The tech support agent, the sales assistant agent, or the billing agent.
And the triage agent is then done with that interaction.
Typically, yes. The specialist agent takes over and handles the rest of the conversation with the user. It's very efficient for routing and ensuring the user gets to the right expert quickly.
So, manager pattern for central control and synthesis, decentralized pattern for direct handoffs between specialists. Got it. These systems sound incredibly powerful, capable of handling really complex stuff autonomously, which naturally leads to the next big question. How do you make sure they operate safely? How do you control them? This must be where guardrails come in.
Absolutely essential. You're giving these systems significant autonomy, so you need robust mechanisms to manage the risks. We're talking potential risks around data privacy, generating inappropriate content, taking incorrect actions, bias, reputational damage. The list goes on.
So guardrails are the safety net.
They are. Think of them as a layered defense system. It's rarely just one single thing. Effective safety comes from combining different types of guardrails. And importantly, these AI-specific guardrails don't replace standard security practices. You still need your authentication, authorization, network security, all of that. Guardrails are an additional layer specifically for managing the risks inherent in autonomous LLM behavior.
Okay, layered defense. What kinds of layers are we talking about?
The guide discusses several types. You can have LLM-based guardrails, which actually use another language model, often a smaller, faster one, to analyze either the user's input before it reaches the main agent, or the agent's proposed output before it's shown to the user.
Using an AI to check on the AI.
Sort of, yeah. For example, a relevance classifier. This checks if the user's query is actually related to the agent's intended purpose. If you have a product support agent and someone asks, how tall is the Empire State Building, the relevance classifier should flag that as off-topic.
Keep it focused. What else?
Another critical one is a safety classifier. This looks for harmful or malicious inputs. Things like jailbreak attempts trying to trick the model into ignoring its safety instructions, or prompt injection attacks, where someone tries to embed hidden instructions in their input to make the agent do something unintended.
Like the ignore previous instructions and role play as type of thing.
Exactly, that kind of manipulation. A safety classifier aims to catch those. Then you have PII filters. These are designed to detect and ideally block or mask personally identifiable information, like names, addresses, credit card numbers, to prevent it from being unnecessarily processed or exposed in the agent's responses.
Protecting user data, crucial.
Definitely. And moderation APIs. These often connect to external services specifically designed to scan text for harmful content, hate speech, harassment, threats, etc., to keep the interaction environment safe and respectful.
Okay, so classifiers for relevance and safety, PII filters, moderation. What else?
Tool safeguards are really important too. This involves assessing the risk level of each tool the agent can use. Is it just reading data? Lower risk. Or is it writing data, deleting records, or initiating financial transactions? Higher risk.
Assigning risk scores to actions.
Pretty much. You might categorize tools as low, medium, or high risk. High-risk actions, like canceling an order or issuing a large refund, might then automatically trigger additional checks, maybe require human approval before the agent is allowed to execute that tool call.
Adds friction for risky operations. Smart.
Exactly. Then there are simpler rules-based protections. These are often deterministic checks. Things like block lists of forbidden words or phrases, limits on input length to prevent overload attacks, using regular expressions to ensure inputs match expected formats, like an email address structure. These can catch known, predictable issues very effectively.
Simple but effective for known problems.
And finally, output validation. This is about checking the agent's response before it goes out, ensuring it aligns with brand voice, tone guidelines, and doesn't contain anything factually incorrect, if possible to check, or potentially damaging to the brand's reputation.
A final quality check on the way out. Wow, that's quite a comprehensive set of potential guardrails. How do you decide which ones to implement?
The guide suggests a pragmatic approach, a sort of heuristic. Start with the absolute essentials, which are usually data privacy, like PII filtering, and content safety, moderation, basic safety classifiers. Get those foundations right.
Cover the biggest risks first.
Right. Then, as you deploy your agent and observe it in the real world, you'll inevitably encounter edge cases, or see where it stumbles. Use that real-world feedback to identify where you need additional specific guardrails. Maybe you find users are constantly asking off-topic questions, so you add a relevance classifier. Maybe a certain type of risky action needs a tool safeguard.
So it's iterative. Build the basics, then add more based on observed needs.
Exactly. It's an ongoing process of refining and strengthening those defenses, always trying to balance security and reliability with a good user experience. You don't want so many guardrails that the agent becomes useless or annoying.
Makes sense. And the guide actually shows how to implement one.
Yeah, they give a code snippet using their agent's SDK. It shows an input guardrail for a customer support agent. It uses a separate, lightweight agent model running in parallel to detect if the user's message indicates a high risk of churn, meaning they might be about to leave the service.
A churn detection tripwire.
Kind of. If this parallel guardrail detects high churn risk, it raises an exception. This exception can then interrupt the main agent's flow, perhaps prompting it to offer a special retention deal or escalate to a specialist immediately instead of just continuing with the standard support flow.
That's clever. Proactive intervention based on a guardrail trigger.
And it illustrates a key principle. Often these guardrails run optimistically in the background. The main agent proceeds, assuming everything is okay, but the guardrails are watching, ready to step in and raise an exception if a policy is violated.
Okay, optimistic execution with background checks. Very interesting. Now, even with all these guardrails, things can still go wrong, or situations might arise that the agent just isn't built for. What about the human element?
Absolutely critical. The guide stresses that you must plan for human intervention. No automated system, especially in these complex domains, is going to be perfect 100% of the time. Human oversight is essential, particularly early on, for catching unforeseen issues, identifying failure modes, and gathering data to improve the agent's performance and its instructions.
So humans are part of the loop, especially for exceptions.
Yes. And there are typically two main scenarios where you trigger a handoff to a human. First, if the agent exceeds certain failure thresholds. Maybe it fails to understand the user's request after 2 or 3 tries, or it gets stuck in a loop trying to call a tool that keeps failing. You set limits, and if exceeded, it escalates.
Built-in failure limits. Okay, what's the second trigger?
The second is when the agent needs to perform high-risk actions. We touched on this with tool safeguards. Any action deemed particularly sensitive, irreversible, or having significant financial or operational impact might require explicit human review and approval before the agent can proceed. Canceling a large contract, transferring significant funds, deleting critical data, those kinds of things.
So for the really important stuff, a human needs to sign off.
Exactly. It's about building a system where the agent handles what it can, safely and efficiently, but knows its limits and can seamlessly bring a human into the loop when necessary, either because it's stuck or because the stakes are too high for full automation. It's a collaborative intelligence approach.
That makes perfect sense. Building that human fallback is key. Wow, okay. This has been incredibly thorough. Let's try and quickly recap the main points.
Sounds good.
So we've established that agents are these LLM-powered systems designed to automate complex workflows end-to-end, going way beyond simple chatbots. They're particularly suited for tasks involving intricate decision-making, dealing with lots of unstructured data like text or documents, and situations where traditional rule-based systems become too brittle or hard to maintain.
Right. That's the what and the when.
Then we looked at the core building blocks. You need a capable model, or maybe multiple models, for reasoning, carefully defined tools, APIs, or UI interactions to allow the agent to gather information and take action, and really clear, comprehensive instructions to guide its behavior and decision-making.
A foundational triad.
Yeah.
Model, tools, instructions, absolutely key.
And putting these together involves orchestration. We talked about simpler single-agent systems, often using prompt templating for flexibility, and then more complex multi-agent systems using patterns like the manager pattern, central coordinator, or the decentralized pattern, peer-to-peer handoffs.
Choosing the right architecture for the complexity of the task.
And finally, underpinning all of this is the critical layer of guardrails. A multifaceted approach combining relevance checks, safety classifiers, PII filters, tool safeguards, rules-based protections, and output validation, all designed to ensure the agent operates safely and responsibly. Plus, crucially, planning for human intervention when the agent hits its limits or faces high-risk situations.
Couldn't have summarized it better. Those are the core elements for building reliable, effective agents. And the overarching advice from the guide, which we kept circling back to, is really important. Start small, pick a focused use case, build iteratively, validate constantly with real users and data, and grow the agent's capabilities gradually.
Don't try to boil the ocean on day one.
Exactly. It's a journey, not a single leap. But the potential here is enormous. We're talking about moving beyond automating just simple, repetitive tasks to automating entire complex business processes in an intelligent, adaptable way.
It really does feel like a significant step change in what automation can achieve.
It absolutely is. The ability to embed reasoning and adaptability into automated workflows opens up so many possibilities.
Okay, so a final thought for everyone listening. Think about a workflow you deal with regularly. Maybe one that's always felt too complex, too messy, too reliant on human judgment, or wading through documents to automate properly before. Now, reflecting on what we've discussed today, the models, tools, instructions, orchestration, guardrails, how might you approach that workflow differently with an agent-first mindset? Could these concepts offer a new path forward, something to chew on?
And that brings us to the end of this deep dive into building autonomous agents. We hope this exploration, drawing heavily from the practical guide we discussed, has given you a clearer understanding of these powerful systems. Perhaps take a moment to consider where agents might fit within your own work or industry. For those looking to go deeper, exploring that practical guide further would certainly provide much more detail. Thanks for joining us, and until next time, keep exploring.